All right, so our next unit is the Light and Optical Systems unit, and our first topic in this unit is called What is Light? All right, so what is light? So light, it is the form of energy that you can see. So there's natural light sources. These are, for example, the sun and fire. They are called natural light sources because they are a non-human made source of light. All right. Here, if we look at this diagram, so besides the sun and the stars, flames and sparks are also natural sources of light. All right, so continuing with light, light also radiates, meaning it sends out energy in the form of waves or rays. So when we talk about radiation, this is the transfer of radiant energy such as light. And radiant energy is defined as energy that is transferred or emitted as waves or rays in all directions. All right, so right now we just talked about natural light source. Next, we're going to talk about, we'll come back to this slide. I just wanted to compare it to an artificial light source. So an artificial light source is a human-made source of light. So for example, light bulbs, flashlights, TVs, computers. But keep in mind that the light from a bulb, it still radiates in all directions, just as we talked about with natural light. Here we're just looking at light from the sun. So again, that's the natural source of light from the sun. It's formed through a process called nuclear fusion. All right, so it's the nuclear fusion of hydrogen particles. So the sun, it's made up of about 70% hydrogen, and when those hydrogen particles, when they fuse or combine together, they form another particle that's called helium. And during that process, an enormous amount of energy gets released as heat as well as light. All right, and the temperature inside of the sun is about 16 million degrees Celsius. So that was just a little bit about the sun and how the light from the sun is formed. We just finished talking about artificial light. And next we're going to talk about the first basic principle of light. So like I said, light, it is a form of energy. So when light gets absorbed by a surface, it can be transformed into different forms of energy. So for example, light can get transformed into thermal energy, which is like heat. It can be transformed into electrical energy or chemical energy. Think about if you're wearing like a dark sweater or a black sweater. Absorption of the sunlight will cause that black sweater to gain thermal energy. Solar cells can change light into electricity. Trees, they absorb sunlight to make chemical energy, which are the sugars, so trees and plants, during the process of photosynthesis. The brightness or intensity of light indicates how much energy a surface will receive. So for example, on a hot summer day, the pavement or sidewalk can start to feel really, really hot. But on a cloudy day, it'll only feel warm because the clouds are blocking out that sunlight. All right, next we're going to talk about incandescent sources. So an object can be heated to high enough temperatures so that it starts to emit visible light, and that is an incandescent source. So if you heat an object or an object gets heated to such a high temperature that it starts to emit visible light, that is called incandescent source. And incandescence is the emission of visible light by a hot object. So for example, candle flames and light bulbs. And what's happening is you're having electrical energy be converted to thermal energy, which then we see as visible light energy. So in this light bulb here, this is an incandescent light bulb. Electricity will heat a metal wire filament in the bulb, which is shown right here. The filament will get really, really hot so that it starts to glow. And about 95% of the energy that's given off by incandescent light is actually released as heat. So it's not a very efficient light bulb. Next is fluorescent sources. So fluorescence, this is the process in which high energy, invisible UV light or ultraviolet light is absorbed by the particles of an object, which then will emit some of this energy as visible light, causing the object to glow. All right, so when we talk about a fluorescent source, this is a source that produces light when exposed to light of a particular wavelength. So we have the UV light or the ultraviolet light energy causing energy to be absorbed by particles, and then we see the visible light energy. All right, so sources, we have a fluorescent tube here. So an electric current from the leaden wires and electrodes causes the mercury vapor inside the tube to give off UV radiation. All right, so if we look here in this diagram here of a fluorescent tube, we're having electrical energy, which is the energy then being absorbed by the mercury particles, shown here. Okay, then we have the UV light energy. Energy is going to be absorbed by phosphor particles, and then we'll see the visible light energy. All right, so the phosphor coating, which is shown right here, on the inside of the tube, it will absorb that UV energy. That coating will then start to glow, which will produce light. So there are some disadvantages and advantages of using a fluorescent tube. So disadvantages are they're expensive to manufacture, they're difficult to dispose of, and that phosphor coating and that mercury vapor inside, they are toxic. Advantages of fluorescent tubes is thermal energy is not as much involved, right? So there's not as much heat waste. There's less waste of energy as heat, and they are more energy efficient, especially compared to this in the incandescent bulb that we had seen here. All right, so the next type we're going to talk about is the phosphorescent sources. They are quite similar to the fluorescent source. So light energy is being absorbed by certain particles that can store this energy for a while. That stored energy will then later be released as visible light. All right, so phosphorescence, it's the persistent emission of light following exposure to and removal of a source of radiation. All right, so the source, a substance, it'll be a substance that gives off visible light released after the light energy has been absorbed by certain particles that have stored that energy for a while. All right, so that light will continue for some time even after the substance is no longer exposed to the light. So that's the main difference, all right, between fluorescent and phosphorescent, is that particles in fluorescent source, they release their light energy immediately, whereas in phosphorescent, they can release the energy after a while. So phosphorescent particles, they take longer to emit light. They can continue to glow for a while, even after the energy source has been removed. All right, here's an example of a phosphorescent source. Inner surface of a television, computer screens is often coated with phosphorus, and these phosphorescent materials, they're also often used in photographic darkrooms. This is a dial in a darkroom timer. It can glow, basically to indicate how long a photograph should remain in various solutions. Right, next is chemiluminescent sources. These are light. This is light that results from the energy released in chemical reactions. So basically, there's a chemical reaction that's going to produce energetic particles that are going to give off visible light energy. All right, an example is like in a glow stick. So when you have a glow stick, there's a mixture of chemicals inside of it. And then when you bend the glow stick, the chemicals will all mix together, which will cause the stick to glow for several hours until the chemical energy is used up. All right, so that was the example of a chemiluminescent source. So again, there's a chemical reaction that's occurring, and the particles will then give off visible light energy. Then we have bioluminescent sources. So bio, anytime you see the word bio, it means living things. So these are chemical reactions that occur inside organisms to provide the energy for light. So bioluminescence is the emission of light produced by chemical reactions occurring inside the bodies of living creatures. All right, so many organisms that live deep in the ocean, they will use bioluminescence because it's so dark as you go deeper into the ocean. There's very little sunlight that reaches far below the surface. So some organisms like fish, they are able to produce bioluminescence to attract prey, for example. Two terms here that you do need to know is luminous versus non-luminous. So luminous is all objects that emit light, and then non-luminous is a substance that does not give off its own light. Oh, an example of a organism that can give off or emit light would be, another example would be firefly. All right, so I do have a video here, a couple videos here to show for bioluminescence. Give me 1 second, just pause it. Okay, so this is the second part of our lesson from last class, and it is the cost of lighting, and we'll also look at ray diagrams. So the cost of lighting, the unit we use for the electric power, it's called a watt, and the symbol for it is a capital W, so that is the unit of electrical power. But the kilowatt is used more often. A kilowatt is 1,000 watts of electrical power operating for 1 hour. So you would represent that like this, kilowatt hour, all right, with a little dot in between. So that is the symbol for kilowatt hour, small k, capital W, dot H. All right, so let's take a look at this one example. How much will it cost to leave a 60-watt bulb on for 10 hours if electrical energy costs 8 cents per kilowatt hour? All right, so look at all the information that we are given. So we have here, it's a 60-watt bulb. It's on for 10 hours, and we know it's 8 cents per kilowatt. 8 cents per kilowatt hour. So the first step we have to do is convert that 60 watts, we have to convert that to kilowatts. So all we have to do is divide by 1,000. So 60 watts divided by 1,000, we get 0.06 kilowatts. All right, next we have to calculate the number of kilowatt hours by multiplying the power in kilowatt hours by the number of hours. We know it was 10 hours. So we're going to take that 0.06, multiply it by 10. We now have our units in kilowatt hours, so 0.6 kilowatt hours. Next, we have to figure out the cost. So we're leaving the light on for 10 hours. So what we're going to do is multiply our 0.6 kilowatt hours, multiply it by the 8 cents, all right, which was given to us in the question. All right, so 8 cents per kilowatt hour, it is 4.8 cents. All right, so the cost of lighting, the cost of leaving the light on for 10 hours is 4.8 cents in this example. Obviously, it's much more now. All right, so the next thing we're looking at here is the ray model of light. So the ray model of light, it's a model of light based on the observations that light travels in a straight line. All right, so straight line is how we're going to model how light is traveling. Shadows occur because light travels in straight lines from its source, and it does not bend around objects. So here, if we look at this image here, we see this shadow. So this person here standing up looks like in a movie theater. So it's the shadow here is the result of light traveling in straight lines from its source, and it does not bend around objects. All right, and then we're going to be making a ray diagram. So what is a ray? It's a single line or a narrow beam of light. It originates from a light source, and it may bounce off a surface that it strikes. Okay, so if we look at this ray diagram, this is a ray model of light. So this ray diagram, it's a representation of the path of light. So you use a straight line with an arrow. So notice here's the light source, our light bulb, and we draw the rays. It's a straight line, and then we also can see the arrows there. All right, so it is an imaginary line. It's showing the direction in which light is traveling. So in this figure, figure A, it's showing us how the distance from the light source affects the size of a shadow that an object makes. So this is a solid object, and so is this one. This here is smaller, but it's closer to the light source. So what we see here is the smaller object is casting a larger shadow because it's closer to the light source. And then here, the other object here, it has a smaller shadow. It's farther away from the light source. And then in diagram B, we can see how we can change the ray diagram, and we can make it easier to draw and to visualize. So again, you usually draw them as though you were looking at the object directly from the side. All right, so the light source is just represented with a dot, and then we have our straight lines shown with arrows, and then the bright areas and the shadows are shown there right here on the screen. Lastly, just these two solid objects that were here are just represented as lines there. So just looking at some key terms. The first term is transparent. If a material is transparent, it means it's allowing light to pass through, right? So it's a clear substance. So when light passes through clear substances, the rays continue along their straight path, all right? So some transparent materials would be air, water, window glass, eye lenses, and so on. If something is translucent, that means it's allowing some light to pass through. The light gets scattered from its straight path. So for example, paper, some types of glass and plastic, things that are translucent, okay? So not completely clear. And then lastly is opaque. These materials do not allow any light to pass through. Opaque materials, they'll cast shadows. So any solid type of material like a desk, a textbook, and so on. All right, so here we're looking at the ray model of light. So in this area here on the left, that's a transparent material. So notice that the light, the rays are just going to travel continuously as if they aren't going through anything, right? Because it's a transparent material. On the right hand side, we have the translucent material. So light is traveling in a straight line until it strikes this translucent material, and then we can see that the lines are scattering. All right, they're not going straight through like they were in the transparent material. All right, and then we have the opaque material, and we can see that the light cannot go through, so they are being scattered. All right, so we're just going to watch a quick video here on translucent, transparent, and opaque.